Okay, so we looked at pressure just kind of like on one object. But what if we have like something with a connected volume and we're exerting pressure on one side? What happens? Um, well, that's kind of when we were starting to use Pascal's law. So if we apply a change in pressure to a fluid and the fluid is incompressible, what we can say is that the pressure must be the same on both sides. So pressure is equal to force divided by the area, right? So if I exert a pressure on one side, so say for example, I have this car on like a hydraulic system here. If I'm pressing down on one side on this, or I have this car basically, and then this pressure or this force here would be like against the weight of the car. I would experience, so if I call this like the pressure on one side and the pressure on the other side, let's say this is like the ratio of, what was this one? F2 over A2, and then this is F1 over A1. This is for my P1, and this is my P2. These have to be equal, okay? And then what that essentially tells me is if I have a smaller uh, um, area on one side, it's going to, like that relationship will affect how my pressure translates across these two ends of the pipeline, basically. So my pressure is going to be transmitted to the other side, but I might see, for example, like a change in velocity if I'm pushing on one side, but I have less area that I'm pushing over, and versus like less coming out. So just sort of the relationships of how we relate things. Um, so because I know that the force, each of these forces over the areas are equal, if force 2 is greater than force 1 by this factor, so the volume of liquid pushed down for x1, which is on this side, right? Um, so if I'm pressing down on x1, right, is equal to the volume of liquid pushed up on the other side by this delta x2, these relationships are true. So I can say a1 times the change in x1, which would be a1, so this is also um, a1 times b1, which is the velocity, because, or sorry, yeah, a1 times the change in x. Oh, sorry, we're not there yet, just the change. So I can say that the area times the change in x is equal to the area times the change in x2. And I can derive some relationships that I might be able to use to solve other problems, basically, because I know that I know that this relationship is true for an incompressible liquid. Okay, so I have two very short problems over here that will kind of like apply these concepts and apply these equations. So I'm going to go ahead and I'll intro one and then I'll stop the video and then give you a chance to try it. So in a car lift used at a service station, compressed air exerts a force on a small piston that has a circular cross section and a radius of 5 centimeters. This pressure is transmitted by a liquid to a piston that has a radius of 15 centimeters. What force must the compressed air exert to lift a car weighing 13,300 newtons? What air pressure produces this force? So the way that we think about this problem is if we look at our diagram over here, this would be where we're applying our force and we want to lift the car on the other side, okay? So we can use this diagram to go ahead and answer this question here. So I'll go ahead and pause the video and then give you guys a chance to try to give it a shot, and then I will go through how you would do this problem.